Hello, this is presented to you by Ahan Devroy, Parek Soni, Ustav Sharma, and Shubham Singh. The user story that is used here is, as a user, I want to be aware of my surroundings much better than I am now because it will help me in my daily activities. This is the core statement around which we built our project. Here in our project, we use two sensors that measure different things that will help the user. The sensing requirement is to detect any change in the environment of the user. The thinking requirement is to detect if any of those changes are real or false, such as if a user meets with a person who they are standing in front of and having a conversation, they should not be identified as an obstacle. And finally, acting required is to provide feedback that is easily identifiable by the user. This is done by making a unique set of beeps or sounds that is produced by the buzzer that is released in case there is a sensing that in case when there is a sensing action going on. Here we demonstrate how the ultrasound sensor is better and more effective than a motion sensor. Here there is a video. As we can see, we move the book closer to the model or model smart stick. The frequency of the beeps increase.
That's really meaningful. Yes, yeah, it will be done. The doctor will do it, yes. And not how long you are there. Yeah, exactly. Because not a lot of treatment will take long.
This simulates the user is approaching an obstacle. If we had used a motion sensor, this would have made a single beep with a fixed interval, which would have given the user no idea how far away the obstacle may be. But this is fixed by using ultrasound sensor, which not only has a transmitter but also a receiver, so it can detect how far away the object really is.
That's really meaningful.
Next, we demonstrate how the LDR works. This is a light dependent resistor and has a low limit of 200 that detects ambient brightness and sets off the alarm when it is below 200. As we can see from this video, as long as my hand is over the sensor, it will keep producing a series of beeps.
A short video of what the system does, or maybe some figures, right? But
This indicates that the device is placed in a dark or is simulated to be. As soon as my hand is removed from the buzzer, it stops beeping or making any sounds.
uh,
This is a burn down chart that was plotted by a total of 800 story points was used, and the original completion for this task was at 80% by 80% or 20% of the work left by the 26th of September, and the completion of the explanation of the task by 29th September, which is the 20% remaining. But due to some complications, we were able to complete the project by 27th of September, that is around 85%, and the explanation and brief description of the project by 29th as planned. This is the final setup of the project that we came up with. As we can see, the main Arduino could not fit all of the sensors, so we opted to use a base shield, which was then connected to the Arduino. This basically reduced the number of wires that connected to the Arduino and made it a lot easier to manage. The ultrasonic sensor and the LDR placed at the bottom of the stick. The LDR is placed at a 90-degree angle so that it detects light that may fall on it and is less prone to getting triggered by shadows. Finally, the buzzer is placed at the very top of the stick, which lets it have a larger impact on the user when it goes off. Then there were many challenges that were faced. Some were finding all the parts, thinking of a way to hold it all together, and refining the code. The only change we had to make to the original idea was to remove the remote from the project. The only reason we did this was because we could not find a suitable receiver for the remote to function. Thank you. This was presented to you by Ahan Debroy, Prek Soni, Utsav Sharma, and Shubham Singh Rathore.